This time projectile is fired from the top of a tower. This is the tower. It is some height h. You have projected a particle horizontally. Can this be considered as two-dimensional motion? Yes, because there is just horizontal and vertical. It is not following, say, sometimes it is going backward, forward, not like that. Either it will go along this x-axis or this y-axis. Everything we can express in terms of unit vectors along these two axes. If we like, if we don't like, then we will not do. When projected, who will control the motion of this projectile? If you are projected with velocity u, then again its vertical motion will be controlled by g on the earth g. So what will happen? It will strike the ground after some time. It will strike the ground this manner. After some time, it will follow this curved path. It will strike here. The point of projection was O. Foot of the tower is M. Where it strikes the ground be A. It will follow a curve. We will find the equation of this curve. We will find velocity at an arbitrary instant, then trajectory, and then what is the final velocity. Let us do step by step. So we have fixed up x-axis this way. Horizontal velocity remain constant. This remain constant. It is equal to u only. It will not change. Because this u not affected by gravity. Gravity acting downward. And it is going downward because of gravity, and that we can find. What is the velocity after time t? Obviously we will write. This point P it reaches, whose coordinate also you can say x and y, and velocity. First we will be writing velocity after time t. Velocity after time t. Vx, no change along x-axis. It remains u. We know initial velocity. If you say that by using equation of motion v0x plus at, I can do, yes you can do, but acceleration in horizontal direction 0, ax is 0, only v0x is there, that is u plus 0 into t. So vx remain u. And what is the vertical velocity? It is vx. We got vertical velocity vy. See, in initial direction, no initial velocity. Initially downward direction, no velocity. So if you say that vy equal to v0y plus ay into t, this thing will be 0 into t, and this is gt. So vy going to be equal to gt. Okay, vx is u and vy equal to gt. It will follow the curve and velocity will be in tangential direction. So resultant velocity v equal to Vx square plus Vy square you can easily write by vector method, and the angle it makes with horizontal, that also you can write. It is Vy by Vx, Vy, this is GT, GT by U. So alpha is tan inverse GT by U. This is number 3. Alpha equal to tan inverse GT by U, the angle it makes with the horizontal. And resultant velocity formula also I have given there, that V equal to root over U square plus G square T square. Take this one 3 and this one 4. Okay. So velocity after time t we got. To find the trajectory like oblique projectile, we need x and y coordinate. What is x? What is y? Let us see. What is x and what is y? We will find it here. If you have taken this one pxy, obviously if you take the position of the point pxy, then this is along x-axis and this is along y-axis. So if we want to write displacement after time t, displacement after time t, that is going to be x equal to u into t, because in horizontal direction speed remains the same, it is v only. Vertical direction y, this is y equal to half gt square, because vertically no initial velocity is there. So you use that equation which we have already done before. It will be y equal to half gt square. Now, how to get the trajectory? I have pointed out in the previous case, in case of oblique projectile. To get the equation of trajectory, you need to eliminate t from 1 and 2. So, eliminating t from 5 and 6. You get t from 5. From 5, t equal to x by u. And from 6, y equal to half g x by u whole square. See, again it is parabola. Why parabola? You will ask me the question. Because this on simplification will give us gx square by 2u square. That is 2u square by g into y. Alright? This is parabola, of course. You being a student of class 11, have passed class 10, 9, whatever. This is a parabola of this form. It will be parabolic. Here also it is parabola. So the trajectory is parabola, which is a parabola. Now, a common question arises. For this projectile, can you define horizontal range? Can you find the time of flight? And what will be the velocity the moment it is striking the ground? Let us see. Let us do step by step. We want to find the time of flight. Let us find time of flight. T. In going from O to A, the vertical displacement equal to h. So initially no velocity is there. So the equation in two-dimensional motion for y equal to ut minus plus half gt square, using that only. For t equal to t, we have taken this time of flight. H is the displacement. 0 into t plus half gt square. Okay. So this implies 2h equal to gt square it is under root 2h by g. This is time of flight. You can use it directly. Time of flight is under root 2h by g. Then what is the range here? This range how will I find? Very easy. This range we can find by considering that initial velocity, which is unchanged. U is the velocity. So every point it remains u. Even when it is striking, I told you the velocity horizontally remains the same, u. Everywhere it is u. This only will help us to get the value of range. The horizontal range r equal to u into t. So it is u into root over 2h by g. This stands for horizontal range. So this projectile when fired from top of tower horizontally, we got everything about it. Now just for the sake of numerical question, sometimes it is asked what is the velocity just before striking the ground or on striking the ground. Velocity at A during its motion, how will you find? Very interesting question. At A. So you forget all those cases, just remember one thing, the time of flight. At the point A, its velocity is u here. In what direction? Horizontally. Forever it is constant. Vertically, this you have to find. But how? Vertically, no initial velocity is there. Motion is under gravity. So this velocity, this is going to be ux vy equal to the time through which it falls. What is the time? That is time of flight. So this is g into t. So you got the horizontal velocity, you got the vertical velocity. And resultant velocity now can be determined here the same manner. So v at A, if you want to find just before striking the ground by vector method, that's why we did vector first, then we are doing these topics. V equal to under root u square plus gt whole square, and the angle alpha here will be Vy by Vx, that is Gt by U. Alpha can be determined from here. Alpha equal to tan inverse Gt by U. That's all. About when the projectile is thrown from the top of a tower. But we don't know it will be thrown horizontally or not. We have considered the simplest case over there. It is thrown horizontally. But maybe it is not thrown horizontally. Then how do you solve the problem? Situation 2.
So if it is like horizontally, but it will fall vertically, right? And so the vertical and the horizontal will be the same.
It is thrown what?
So like it's thrown in a horizontal way. Like it has to fall down vertical. It can't fall down horizontally. And so like both the vertical component and the horizontal component be the same then.
No. That when it is striking, time is the same, but it is not following straight line path. It is following parabolic path. It is motion in curve. Okay, that's why this discussion is required. Now I am going to discuss the case where you will throw the projectile at some angle with the horizontal. From the top of tower, you are throwing it in this manner at some angle with the horizontal with velocity u. Situation may be like this. It may be like this also. You can say that why I can't throw this manner. Of course you can. This angle is also theta, and you are performing the experiment from the same height of the tower. How to find the time of flight, horizontal range, all those things? There is no chance that particle will follow straight line path here in these two cases. It will follow parabolic paths only. But how? Let me show you. We will not derive any exclusive relation here. I'll just tell you equations. From there we will solve numerical problem. So what kind of path expected to follow? Of course it is a parabolic path. But that proof we will not do now. It is a moving curve. Just using previous concept saying this one parabolic. If it is asked to prove parabolic, we will do. But then they have to give some initial values. Then only we can prove. Otherwise with the variable, it will be difficult. We are not going to follow that path. This is our x-axis. Say this is our y-axis. Same thing, same way. You want to find the time of flight. When throwing from here, after what time it will strike the ground? For this projectile, this is our case 1. When fired at some angle with the horizontal. So let us write the components of velocity. U cos theta. This will be U sin theta. Clear? Now, U cos theta, as I told, it is not governed by gravitational acceleration. At any point, U cos theta will remain the same. Only U sin theta part will not remain constant. Definitely it will change. So let us find the time of flight first. T. When time t equal to t, the vertical displacement h or y, whatever you say y is equal to h. So this equation h equal to minus u sin theta into t I have written correctly. Check once. Why minus u sin theta? Because it is displacement downward. And initial velocity is in upward direction. That's why it is like that. Minus u sin theta t plus half gt square. So this you will not find exclusively. If they have provided data u and theta, then you can find t. So solving this equation, t can be determined from above equation, just by solving the quadratic equation. The question is how to find the range. I told you I will be discussing the method, then we will apply in solving sums. So here r is the horizontal range. We are going to find this value of r. R equal to u cos theta into t calculated above. You have calculated the value from there. That value you substitute here, you will be getting r. So this method apply in solving sums. Now let us apply it in solving one problem. Here I am just writing it for you. See how these equations enough to solve the problem. Just draw a diagram. This is say 40 meter. Particle is thrown with velocity say 20 root 2 meter per second. Question is same. Find time of flight and horizontal range. Trajectory you know. Okay, this is the trajectory. This path will be followed by this angle given 45 degree. This angle they have given 45 degree. Your problem is to find this range and time of flight. So what I am going to do, I'll keep these equations in my mind. It's there in my mind already. I'll be using the equations we have got there. So h equal to what? 40. For this sum, 40 equal to minus u sin 45 into t plus half g you take 10 into t square. So this is 40 minus 20 root 2 1 by root 2 get cancelled plus 5t square. So t square minus 4t minus 8 equal to 0. All of you can find it. 4 plus minus take from here 48, that is 4 root 3 by 2. Time cannot be negative. So we got t equal to 2 plus 2 root 3 second. This is nothing but 2 into 1 plus 1.73. 2.73. 5.46 second. Obviously range can be determined now. You use this formula, range equal to, this will remain the same, that is u cos theta. I mean this 20 forever same. So that 20 into the time of flight you got here. This much meter. So this is the answer for range here. Understood? Let us do it for this case now. It is projected with velocity u at an angle theta with the horizontal. How do we account for its time of flight? Let me write the equation, then one numerical will solve. And in fact, we are going to compare the time of flight in this case and in this case. Let's see the equation of motion here. What kind of equation of motion? This is case 2. This velocity is u cos theta. This one is u sin theta. Okay. So the path it going to follow will be parabolic. It will follow definitely a parabolic path. Not this much line. Almost like this. O, A, and bottom of the tower is M. So component this way u cos theta, this way u sin theta. You write the equation of motion, time of flight. How to account for this? That h equal to g is operating the downward motion. H equal to 0 in, no, not 0. It has u sin theta. So h will be u sin theta into t plus, because h and g have the same direction. This is say number 1 in this case. T can be determined, you can say that just only that T can be determined from above. Then T can be determined from above. Range is going to be what? Range will be u cos theta into T. Which you have got there, the value of T you put here. The same manner, only equation of motion is little bit changed. We are going to solve the same problem, that velocity of projection keeping that same, angle of projection is also same, but this time projecting downward. Let's compare the time of flight. So the situation I am going to discuss this one. Projected this manner, it will follow this kind of parabolic path. This is 45, 20 root 2. Here it will be 20 root 2 cos 45, 20, and this is also 20. This height of tower is 40 meters. Okay. So now what you are going to do, we are going to use this equation obviously, that h over there, u sin theta plus so this implies 20 equal to 20 plus 20 t, sorry, this t. So t square plus 4t minus 4 equal to 0. Divide by what? Divide by 5. So now it is going to be b square 4ac by 2. Root 32. Root 32 is 16 2, that is 4 root 2 by 2. So this is minus 2 plus 2 root 2. You cannot take both negative. So time of flight is going to be 2 into root 2 minus 1. It is 1.41 minus 1. This is 0.82 second. And this will help us to get the value of R. R will be what? 20 in horizontal direction, no? So along this direction it remains 20 forever. So the answer is 16.4 meter. It's alright. Hope you have understood projectile, these two cases also. Now at the end, I'll give you one task at home, that can you write all the motions, all the projectile motions we have discussed before this session also, using vector. Can you write R vector for all the projectiles? This work you will do at home, and before the next session starts, you will be completing the NCERT work. Definitely you will do it. Okay.